Hello, welcome to this video. We learn about how does a tokenizer works and what is happening inside it actually. If you are new to LLM, you might have heard a lot about tokenizers. Each of the model or a large language model like GPT, LLaMA has its own tokenizer. Tokenizers are key how a model sees and learns. In simple terms, tokenizer is like a translator. It turns words into numbers, and numbers are what finally are given as input to the LLM because it actually cannot work directly with text. More formally, tokenizer is a tool that breaks down text into smaller pieces, which we call tokens. Tokens can be words or parts of words. For example, for complex words, we break down into several subwords or even characters. There are some special characters, spaces, some opening, closing brackets, and so on. The input text actually what is given as input to the tokenizer, and this text can come from different sentences or paragraphs. Tokens are split like this text into tokens, so we get multiple tokens from this sentence or paragraph. And finally, these tokens are converted into numbers or IDs, and these IDs are what LLM actually learns or trains on. It's very important because in a way, tokens help model to understand different words, and model can actually learn some new or complex sentences or words easily because indirectly it's just saying these as numbers. Uh, in this notebook, we'll look at GPT and LLaMA, and we'll see how the tokenizers have slightly changed over time. And LLaMA is most specifically one of the recent model, the 405B model, which is almost as good as the closed source models. There are some functions here. In the first function, we'll use tokenizer converting to IDs, and we'll see how the IDs look like. We'll also get a data from which will kind of map tokens and IDs together for visualization purposes. Finally, we will also try to reconstruct sentence from just the IDs, like what are given as input to the model. We'll see if there's any loss in information here or not. I'm taking three simple examples. First is just a simple sentence here. Second is like a sentence where I've had a little Hindi in it. So it's a kind of multiple language, multilingual sentence. We'll see how these kind of special characters are handled. And finally, I've written a function. Nowadays, we want LLMs to learn and write code, and we'll see how the functions are tokenized. Uh, First, let me take a GPT-2 tokenizer. And GPT tokenizers are actually very kind of widely used in the community. They serve as baselines, and they have actually revolutionized actually how LLMs and tokenizers are seen, and they are designed specifically. But let us run it on different tokens and examples. I have three examples. We'll get the tokens. We'll just print the data frame to see how it looks like. Uh, so the first example we had was the cat sat on the mat. Here, the tokens are broken down. We have about 6 tokens, and each of the token are assigned different IDs. What these 6 tokens are actually saying is, the, of course, is a token. This special character which appears is actually representing that there's a space before cat. So how GPT-2 handles is that it represents these as spaces as with this extra character. So in a way, it is telling model that cat is not alone. It is actually, there's a space in front of it. Similarly, I love programming, and this is a Hindi kind of special character which starts. Again, the special space is coming as a special character. After and these like extra tokens 1, 2, 3, 4, 5, 6. The 6 tokens are actually representing that Hindi word, and that Hindi word is khana, which actually means eating. So it's like I love programming and eating, but those special characters actually being in a different language, GPT takes a lot of tokens to represent them. In this way, we can also see that GPT is designed very well to handle English, but beyond that, its tokenizer has to have a lot of tokens to represent at even one single word in Hindi. Whereas in English language, each of the word is represented with just one token. Now let's look at the Python example, which I had. Let us again go here. This is a simple Python example. It's a Python function input I, and just checking if I greater than 0, writing some special operations. But we'll see how these all things are handled. But most important thing about programming languages is that, like you see, Python has indentation. The spaces which are coming in front actually matters. How model handle these spaces or understand them actually is critical to how good the model will be on learning this programming or generating programs. As we know, GPT-2 is not a very good programming model, but LLaMA 405B is. So we'll see the difference in these two models in a moment. Looking at the tokenized programming example. In this one, in the simple program, it has to actually create 33 different tokens, and all of these special kind of tokens are, brackets and I are separate tokens, function and Python are broken down as two tokens. And again, this special kind of what you see symbol are here representing those extra spaces which are coming there, and so on, new lines and whatnot. Again, this greater than 0 is represented as two different tokens. Plus is equal to is represented as one token. And now let us see if we can reconstruct these sentences back. So again, we get the tokens and IDs, but now I'm passing it to reconstruction function, which actually just uses the IDs to see if tokenizer can be reversible operation. It does reconstruct everything back as it is. So in a way, it has not lost any information. GPT-2 tokens just construct back in these three sentences. There might be other tokens which I have never seen, so it just adds a special character or special token there. And when you revert it back, we might not get exactly. But in these three sentences, it has actually constructed them perfectly back. Now let us look at the LLaMA tokenizer. LLaMA tokenizer is like a model which works very well on code generation, and we are taking 405B model, the latest model which just released a few days ago. Again, let us load the tokenizer. To note that I had to pass the oath here in my notebook. Like, so when you are trying to load this LLaMA tokenizer, you might have to get access on the Hugging Face, or you might have to request an access there. Again, the same examples, and let us see how now they look like. Here again, like interestingly, even LLaMA 405B has a special token pairing for the space. But another interesting thing is, right, let us look at the previous example where for the Python function, we had around 33 tokens. Now here for the Python function, the same Python function, we have only 19 tokens. So a lot reduced. Why it is happening is because now it has like a different way, different tokens are combined. Some of the tokens actually are specialized here where they represent different spaces like you see here. So most of the time when you see different spaces like which appear, like before this a lot of spaces appear, it is actually a special token or a special ID is assigned to it. What it means is, so let us look at the function. So this extra space which kind of appears here is just one token in LLaMA, but in GPT, it was handling each of these as a separate token. So now you see that because model is actually specifically designed so that it can process codes, researchers have taken kind of due diligence to define tokens intelligently. In a way, moving from GPT to LLaMA, all of this intelligence comes into picture in design of tokens or tokenizers. And finally, these are the tokens which we gave as input to the model on which model is trained. The better the tokenizers are, the more intelligent the models are on handling of our specific tasks. I hope this serves as an introductory video to get you acquainted with the tokenizers. I'll see you in the future in another video.